So here we have the function f of t equals 3 times t raised to the power of 5. So we have to determine the Laplace transform of the given function. So Laplace transform of the function f of t is, so we have 3 times t raised to the power of 5. Now 3 is a constant, so we can pull it out of the operator. So that means we can also rewrite it as 3 times the Laplace transform of t raised to the power of 5. Now we're going to use the property that t raised to the power of n, the Laplace transform of this particular function is going to be equals to n factorial over s raised to the power of n plus 1, where s must be greater than 0, and this particular formula holds when n belongs to the set of natural numbers. So clearly in the exponent of t, which is 5, is a natural number, so we're going to use this particular formula. Then that gives us 3 times n factorial, which is 5, so we'll have 5 factorial over s raised to the power of 5 plus 1. So we have 3 times 5 factorial is 120 divided by s raised to the power of 6. So 3 times 120 is 360. So we have 360 divided by s raised to the power of 6. So this is the Laplace transform of the function 3 times t raised to the power of 5. Of course, s must be greater than 0. Let's move on to the next question. So here we have the function f of t equals 4 times cosine of 5 of t. So let's find out the Laplace transform of this particular function. We can pull out the constant 4 from the inside to the outside, meaning we can pull it out of the operator. So that will be simply equals to 4 times the Laplace transform of cosine of 5t. Now we know that the Laplace transform of cosine of at is given by s divided by s squared plus a squared. So here s, where the value of a is 5, so that gives us 4 times s divided by s squared plus 5 squared. So we have 4s divided by s squared plus 5 squared, which is 25. And of course, the value of s must be greater than 0. Let's move on to the next question. So here we have the function f of t equals sine pi of t. So let's find out the Laplace transform of sine pi t. So we're going to use the Laplace transform of sine a t. So that's equals to a over s squared plus a squared. So we'll have a, which is pi. So pi divided by s squared plus a squared. So a squared is pi. So we have s squared plus pi squared. And of course, s is greater than 0. Let's move on to the next question. So here we have the product of two functions, sine t and cosine of t. So we need to determine its Laplace transform. But before finding the Laplace transform, let's try to apply some trigonometric identity here. So we're going to multiply and divide by 2. So we have half multiplied to 2 times sine of t times cosine of t. Now that's because 2 times sine of t times cosine of t is sine 2t. So that means finding the Laplace transform of the function sine of t times cosine of t is the same as finding the Laplace transform of half sine 2t. So that will be half multiplied to Laplace transform of sine 2t. So we have half multiplied to Laplace transform of sine 2t will be a, which is 2, divided by s squared plus a squared, which is 2 squared. So the 2 and 2 will get cancelled, leaving us with 1 over s squared plus 2 squared, which is 4, and of course s is greater than 0. Let's move on to the next question. So we need to determine the Laplace transform of the given function. So Laplace transform of 3 times t raised to the power of 4 minus 2 times t raised to the power of 3 over 2 plus 6, which will be equals to Laplace transform. So here we're going to apply the linearity property, meaning we're going to apply the Laplace transform to each of the 3 terms individually. So we have Laplace transform of 3 times t raised to the power of 4. Now here 3 is a constant, so we can pull it out of the operator. So we have 3 times Laplace transform of t raised to the power of 4. Similarly, we have negative 2 times the Laplace transform of t raised to the power of 3 over 2 plus 6 times the Laplace transform of 1. Now for the first term, so we need to find the Laplace transform of t raised to the power of 4. So 4 here is a natural number. So for the case of the natural number, we are going to apply the formula that t raised to the power of n is simply equals to n factorial over s raised to the power of n plus 1. So we have 3 times n factorial, so that will be 4 factorial divided by s raised to the power of 4 plus 1 minus 2 times, now here we have t raised to the power of 3 over 2, so that 3 over 2 is a rational number, so we have t raised to the power of p, so that is simply gamma p plus 1 over s raised to the power of n plus 1. So we have gamma 3 over 2 plus 1 divided by s raised to the power of 3 over 2 plus 1 plus 6 times the Laplace transform of 1 is 1 over s. So 4 factorial is 24, so we have 3 times 24 divided by s raised to the power of 5 minus 2. So the gamma of 3 over 2 plus 1 will be equals to 3 over 2 times gamma of 3 over, it's 3 over 2 divided by s raised to the power of 3 over 2 plus 1 is 5 over 2 plus 6 over s. So here what we have done is the gamma of p plus 1 is equals to p times gamma p. So here 3 over 2 can be now rewritten as gamma 3 over 2 can be rewritten as gamma of half plus 1, which will be equals to half times gamma of half. Now, half times gamma of half is square root of pi, so that means the gamma value of 3 over 2 is simply square root of pi over 2. So we have 3 times 4, which is 72 over s raised to the power of 5 minus 2 times 3 over 2 times square root of pi over 2 divided by s raised to the power of 5 over 2 plus 6 over s. So the 2 and 2 gets cancelled, and that leaves us with 72 over s raised to the power of 5 minus 3 times square root of pi divided by 2 times s raised to the power of 5 over 2 plus 6 over s. Of course, for all the cases, s must be greater than 0.